Join Tom, W5 Cub, and Brett, Y7BG. Talking antennas, DX, and radio fun. Making friends around the world, one contact at a time. Amateur Radio Roundtable, where the ham radio world comes together.
All right, that should have woke you up right there. Oh man. All right, welcome everybody to Amateur Radio Roundtable, a show about ham radio, amateur radio, shortwave, electronics, and a few other things. And we really welcome you tonight. Let us know where you are, and especially if you're listening to us on shortwave, on world famous WBCQ shortwave station on 7490. We're on there on Thursdays from 5 to 7 p.m. So if you're listening to us on Thursday. The show is live on Wednesday, the second or fourth Wednesday of every month. Hey, join our Facebook group. It's just called W5KUB. Do a search in the Facebook search bar, W5KUB. Get you right here, and we'll approve you. You can be a member. We got just a little under 15,000 members in that group there. And if you would, please subscribe to the channel. If you have a subscribe button there somewhere, please click on it. It helps us out. Hit the like button if you like anything here. Hit the like button and the notify button too. All that will help us out a whole lot there. And also, we're on every podcast carrier out there, audio only, called like iHeartRadio, Google Play, and all out there. Let's see, what am I missing here? Send us an email if you're listening out there. I don't care if you're on a podcast or if you're on shortwave or just watching the show. We'd love to hear from you. Send us an email to tom@w5kub.com, tom@w5kub.com. We'd love to hear from you. All right, let me think. Got a lot of things lined up tonight. Several people have asked how we get the data from our pico balloons down to APRS, where we see altitude and voltage and all those things. Well, we don't have an APRS transmitter on the balloon, so we're going to tell you and show you how we get that data and how we know what is what. So we're gonna talk a little about that tonight. Hey, I got a piece of test equipment I'm gonna show you tonight. It's gone bad. Not sure what to do with it. Got it on eBay right now, parts only. We'll see. Hey, look at this, guys. We'll talk a little about fiber. Look at here, man. Look at this fiber. I got fiber in front of my house now. I didn't think I'd ever get it, but yeah, it's kind of neat watching them weld the little glass together, man. They got this little machine. They stick those things in there and it just welds it together, man. You know, I wonder if super glue would work. Okay, let's see what else. Field Day Memphis. Brett's going to talk about Field Day here in a few minutes. Hambot. Hambot's going to give away a prize tonight, and some lucky winner is going to get their choice of a dual band HT, a G5RV antenna, or the Explorer backpack. We'll explain all that later. I'll just tell you here, and I'll remind you later. Hambot is going to pick the name out of our chat room, and it is our chat room only. If you're in the YouTube chat room, sorry, you're out. If you're in x.com, sorry, you got to be in the chat room for our show, and the easiest way to get to it is just go to w5kub.com, w5kub.com, and up at the top, I think it opens the page at the video and the chat room are on. So all you got to do is enter your name there or your call letters, and you'll be eligible for a prize, and Hambot might pick your name tonight. Let's see what else coming up. Hey, we got the Huntsville Ham Fest coming soon. We'll have the chair of the Huntsville Ham Fest come on here next show. That'd be Mark Brown. So we got a lot of things going. I got a few other things to talk about tonight if we have time, and I need your help. I need your help to identify something, so that'll come probably a little later tonight. And it's not necessarily ham related, although it has been used for ham radio for a number of years, and I'll surprise you with it in a little while there. So come on in here, Brett. How you doing, man?
Oh, it's been an exciting week. It's been really hot temperatures and then rain and then more very high temperatures and then more rain out here in Laramie. We just had a tornado warning this evening. And the heat dome that was over the east coast where you are has moved to where I am. And so now we're getting temperatures in the 90s and occasionally going up close to 100. And it's a good time to work outdoors, but it's not a great time to work on hot asphalt roofs. So I've been doing my work early in the morning when I've had to climb and do antennas or anything
Well,
like that.
you must have low humidity there, because when we get 100, I think we had feels like 110 this past week. And I tell you, we have humidity here probably upwards in the 90% range. You go outside and you just get soaked, man. You can stay out maybe 5 or 10 minutes, and that's it. The heat's not that bad if the moisture's not that bad.
Yeah. Well, we are at 7,300 feet, and so the humidity isn't too bad up here. But boy, the sun is intense. You need to put on your sunscreen, or you get toasted pretty easily.
Well,
Yeah.
we're not quite as high as you. We're 193 feet.
Yeah, there it's almost sea level.
Yeah.
But so I was on top of roofs doing things like I was having a house painted, and I had to clear brush from the roof. And while I was up there, I was working on antennas too. And I had to do it early in the morning because it got hot. Even though it was dry, it got extremely hot. And so I was doing that. I'm back from my trip to Des Moines, Iowa, and looking forward to the Huntsville Ham Fest, where I will be there. And just generally doing summer things, as much as I am. All the weather's good.
All right. Hey, do me a favor. Stretch your neck. Make your head about 1 inch higher. There you go. Right there you go.
Here.
Wait, now down a little. The head down a little. You were perfect. You were. Oh, right there. Oh.
I'm adjusting my camera. If I turn my camera down just a hair, my head's
Oh
gonna go
man. You look crazy, man. Crazy.
Right.
Oh man.
There we are.
Oh
Okay.
boy. Hey, that looks good.
I don't know whether I'm Huey, Dewey, or Louie, but
It looks real, man. It looks real.
yeah, there we
Oh
go.
man. Yeah. All right.
And I'll be excited to hear more about what you're doing with the balloons, because I know you've been preparing
Yeah.
another one.
Oh, gee, yeah. We've had bad luck on the last two, and oh man, I'll talk a little about that in a few minutes. Why don't we go ahead and get started, and let's get your part on the ham field day that you went to. Why don't we talk about that for a few minutes?
Yeah,
So
well, I was
go right ahead.
Yeah, well, I was traveling during field day, and I was in Des Moines, Iowa, for a music conference, where, by the way, I did perform a song about ham radio.
Oh, really?
Yes, that I performed on this webcast before,
Yeah.
and it was pretty well received. Also went to visit the Des Moines Radio Amateurs Association, which had a big field day station. They had a 5E station, and I'm gonna go ahead and show some pictures of what they were doing. It was impressive. Pulled up, saw this big dipole out there, and it turned out that that dipole was also hanging off of a big tower which was there permanently. That's over 5E and not 5A, and but they'd installed more antennas on the tower. Here we have a dipole. It looks like a trapped dipole here that they had out in the courtyard. And then let's see, go here, you can see they had an emergency trailer, and then they had a crank-up tower on a trailer with a big beam on top. And I got some close-ups of that so you could see. They were also using generator power. So they had a Honda generator running everything. Now, take a look at this crank-up tower. It's on a trailer they staked it down so that it wouldn't fall over or hit power lines or anything. And on top
Yeah.
of there, a big beam and also a wire antenna that's strung up there. So they actually had two antennas up there.
Wow.
Here's a closer look at the crank up.
Yeah. Hey,
So
I noticed, and I think you get points for this, but I noticed that I did not see a ground rod at the generator. I'll just make note of that. I may be wrong.
yep, yep. And here is on the other side of the building. This was done at a museum building. There was yet another crank up tower and another big beam, and then some more antennas above that. So you can see there are these there were UHF and VHF beams as well.
Hmm.
So they were. You're speaking of ground rods. That's one of the things they were doing. They were driving in ground rods to give themselves a really good ground for the antennas on this tower, and so they were making a ground field there, and then starting to raise the antennas. And you can see them. You can see the antennas slowly going up as they went ahead and telescoped the crank up. They had a winch, so they didn't have to do this by hand. So
Yep.
then inside, they had a 5E plus setup because they got a bonus station. So there were actually 6 stations inside the building. Flex radio here, nice one. You can see the Wi-Fi router because they had everything networked with N1MM. I met the other Tom M1MM at Dayton this year, by the way. And that has networking capabilities, so they networked everything. And 2 stations there, another one there, looking around the room. More stations on that side of the room, and I'll give you close-ups of them in a minute. And then a status display which showed how everybody was doing and what sections they had worked. So they had a very elaborate setup. Here's one of the SSB phone stations. You see, that's that's a 7300 there. And there's a Yaesu that's Navi. You can see it's on 6 meters. And there's a little mobile rig that they were using as one of their base stations. And this was just as field day was getting going, so they were monitoring everything. One thing that was interesting that with all of these stations working on all of these bands, they actually weren't using any bandpass filters. They were relying on separation between the antennas and just the radios themselves to keep interfering with one another. And they actually did a pretty good job of that. I was impressed with how well they did, considering that they were not using bandpass filters of any kind. So here's another shot of one of the digital mode stations. So they had, and here is, and here's a Go box that somebody brought. So yet another rig. And again, they tracked everything that they were doing on a map so that they could see when they'd worked all of the ARL sections. So I was very impressed by all of this. Here's the here's the QSO summary screen they had up, which shows who they'd worked and in what modes. Now the club where I am doesn't have anything this impressive. We do work a lot of stations that, from here in Laramie. We didn't have this impressive digital setup. But these guys really went to it, and you can see this as they started up. I went ahead and looked them up on PSK Reporter, and they were getting out everywhere on all bands and all modes. They were doing a great job. So Field Day isn't officially a contest, but they were sure set up as if they were contesting, and that was just fantastic. Their call sign was W0AK. And I'm sure a lot of people worked them. I actually I heard them working call signs of people that I recognized. So they were getting out there, and so I participated in that a little bit, and they also had a big potluck meal there. And then also I had UHF and VHF in my car, and so I did I've worked a few stations from there, but I wasn't really able to do much from my car. But it was still a lot of fun getting out for field day. And again, then I went back to this music festival, and I did a song called "Seeking You," which has the one that has the Morse code on the string part. And everyone really seemed to like that. They really liked the fact that there was that I was doing Morse code, and it was a samba. It wasn't just it wasn't just some just me strumming a guitar. So that was my field day, and that was it was a lot of fun. I definitely enjoyed seeing seeing the elaborate station and how they were working, and and doing a little operating myself. And Tom, we can't hear you. You're muted.
Yeah, how was the temperature during field day out there?
Out there, it was 70s to 80s, so it wasn't too bad. It was actually really pretty pleasant.
Oh, that's not bad.
That wasn't a super hot field day.
Well, I was going to show you some pictures of our field day here. There was this lady that worked in CW. She had a little tent set up. The door zipped closed, and she was running an air conditioner in the tent.
Wow.
Yeah. Yeah.
One of those little portable units?
I guess it was a small unit, yeah. Yeah.
By the way, one thing about the club here in Laramie, Wyoming, where I wasn't, was that some of the students that I had taught, there was a ham radio summer camp here in town. Some of the students that I had taught were going out and working the rigs here on field day, and then they went back to class, and the week after field day tested for their licenses, and we had roughly a 50% pass rate. So we did pretty well with these kids, giving them a crash course in ham radio and having them test.
Now,
The rest,
is this the ones? Yeah,
Yeah.
is this the kids that built the crystal radio?
Yep, the same kids that I was teaching. I taught two segments of the course. The first one was about crystal radios and what was going on inside the crystal radio and how it worked, and the second one was about digital modes. And we actually did digital modes across the room. I set up two computers with just their microphones and their speakers, and I fired up WSJTX, and you can actually do FT8 over audio.
Yeah.
So we didn't need rigs, and we were able to do QSOs across the room.
Well, great. That's good. I'm glad you're getting involved, and hopefully we'll have some new hams here.
Oh yeah.
Yeah.
Well, we have five from that testing session, and then the others we've got them the promise to keep trying, because many of them of that group, most of them came pretty close.
All right. Well, maybe next time they'll get it
Yeah.
if they just don't drop out. Yeah. Okay. Great. All right. Hey, I tell you what. Let's do. Let's do hambot. Let's get hambot in here right now. He's itching. He's itching to give a prize away. So, guys, listen. We're fixing to do hambot. He's going to pick a winner. Now, here's what you got to do. You got to be in the w5kub.com chat room. If you're in the YouTube chat room, you will not be eligible. If you're in an X, you will not be eligible. We're streaming on several different services, but if you'll just go to w5kub.com, you will see the video on the left, and you'll see where you can log in the chat room on the right, and just type your name in there, your call letters, whatever. All right. So you've got about 3 or 4 minutes here before hambot picks a name. Now, everybody knows the rules. Hambot's going to pick a name. He's going to give you 60 seconds to claim your prize. If you don't claim your prize in 60 seconds, hambot's going to say time is up, and he's going to count down. He's going to say, 20, 15, 10, 5, 4, 3, 2, 1. if you don't claim your prize in the allotted time, hambot's going to pick another name, and we'll go through it until we can give the prize away. Now the prizes today are going to be what we've been giving away each week. It's going to be from Gigaparts, and you're going to get your choice for from a dual band handy talkie, or a G5 RV junior dipole, or an Explorer backpack. So you get the choice of, if you're the winner tonight, you'll get to pick whatever you want. All right, so you might send me an email or something if you're the winner, and make sure we have a good address for you. Like, is the address good in QRZ? If not, you need to tell us what it is. If we have trouble getting in touch with you, that's going to void the prize, believe me. I've had some people that didn't tell us who they were, where they were, and it took us a year to find them, and I don't want to go through all that again. So that's Hambot. He's going to pick a name here in a minute. Let's see. Where's Hambot? Hambot's here somewhere. Let's see. Yeah. Now, you don't mess with Hambot. Used to, when I did it myself, you could argue with me that you came in on time or you whatever, and I would always give in and give you the prize. You can't argue with Hambot. Just, it's what it is what it is. And guess what? We used some of that WD-40 that Chris sent us, AB5CB, I think, or is it AA or AB? I forget. Well, you know Chris, down in Florida. Anyway, so we put the WD-40 on Hambot, and he's doing good. So you got about a half a minute, so everybody log in to w5kub.com, get in that chat room. All right. Well, let's see here. Okay. Well, Hambot, are you going to give away a prize? All right. Okay. It looks like he's ready to give out a prize there. So, all right. Watch the chat room. Now, one other point. If I say anything on audio, that time does not count because we have a delay in video. The chat room is almost instantaneous. So we're going by chat room time. So let's just see what happens here. Let's see if we can get Hambot running. Hambot, go ahead and do your thing. Let's see. What do you say? I can't read it. Let's see. Time for another prize. Okay, he kind of gives you a little instructions there. Okay. All right, Hambot, go ahead. All right. Hambot jumped on it. What? Already? Did we? I don't know. Did we get a winner? Yeah. Man, that was fast. KA2, what's that?
OFM.
OFM, K2OFM. Let me write that down. Put it in our log here. KA2OFM. Make sure you're good in QRZ, your address and everything, so we can get this prize to you. You'll be hearing from Gigaparts real quick. They'll send you an email just to verify your address. And let's see, back to the prize. Just one more thing, guys. If you purchase things from Gigaparts, if you use promo code W5KUB, promo code W5KUB, you'll get 2 times the points on all your purchases. So don't forget to do that. All right, well, congratulations, K2OFM. As the winner.
White Plains, New York.
Where's he from? New York, huh? All right. In New York. Very good. And just give them a week or two to get that out. I think a while back when we started, we were giving away just the HT, and they were out of stock on the HT. So we decided to give you a choice on things, so you get to pick maybe some other things that are in stock. I think by now they've got the HTs back in stock if that's what you want. So congratulations, KA2OFM. And Okay, boy, man, you guys are really good on this. You know, we used to give away a couple $1,000 every Hamfest, live at the Hamfest, and sometimes we'd be giving away a $500 prize, and Hambot have to go through 3 or 4 people before he would get a winner. I can't understand that. You guys are jumping on it instantly, man. In milliseconds, you're on it. All right, very good. All right, you're watching Amateur Radio Roundtable, a show about ham radio and shortwave electronics. We're on every second and fourth Wednesday at 8 o'clock p.m. Central Time. You can also hear us on shortwave on 7490 on Thursday afternoons. All right, everybody, just stand by a minute. We'll be right back. Stick around. Any ham radio conversation in ICOM is bound to come up. The reason's pretty straightforward. Solid state receivers, clear audio, and a layout that feels natural the second that you start operating. These radios are made for real on-the-air time, whether the bands are calm, crowded, or somewhat in between. The new IC7300 Mark II builds upon everything operators loved about the original IC7300, elevating it to a sharper, cleaner, and more capable HF experience. Its improved RMDR, lower phase noise, enhanced cooling, and expanded I/O options make it a next-level performer for serious operators who want crystal clear reception, rock-solid transmit quality, and a modern convenience. Built for satellite, EME, and weak signal enthusiasts, the IC9700 continues an all-mode operation on VHF, UHF, and 1.2 gigs with SDR precision. Its real-time dual-band scope, full duplex capability, and high-power output make it the ultimate transceiver for operators pushing the limits above 50 megahertz. For more information about ICOM's amateur radios, please visit icomamerica.com/amateur. All right, guys, we are back. And KA2OFM, I understand from the chat room that you are okay in QRZ, so no need to send me an email. I'll just take note of that. Thank you so much for joining us, and congratulations on winning. And you actually did better than, I think, John a week or two ago. Yeah, I don't know if Brett, you remember when John won nothing?
Oh yes, that was an exciting prize.
Yeah. John won a test prize, which was nothing. It just amazes me sometimes Hambot plays little tricks like that, and I don't know. I guess it's okay. It's all fun, and John didn't get too upset. John, I did ship that nothing out to you. I think the day after, so you should already have the nothing. Okay. All right. What are we gonna do? Oh. Okay, well, you guys, that we are getting ready to fly another pico balloon around the world. This is a little 30-inch party balloon with a tracker on it that we transmit through Whisper on 20 meters to track us, and it gives us every 10 minutes. It plots it on the map. We can see on that map where it is every 10 minutes. And we can see things like the voltage. We can see, the altitude, the course direction, and things like that. And our best flight has been 454 days, I think, about 25 times around the world. And we've launched 2 the past couple months, and they have not been very good. After some research, the one we launched last week, I think we hit a 60,000-foot storm. And that was not good, especially when you're only flying 40,000. You get into storm clouds that are 60,000 foot high, and they're pretty severe. So we lost it. I only put about 70 or 80 man hours into building that and testing and rebuilding, and it did last about 4 hours as far as I know. So I don't know if that's good payback or not. We hope this is better. We're going to go very bare bones on this one. And I'm going to tell you in just a minute how we get that data back. And you might be interested to know what it takes just to get the data back. Let's see. I've got some pictures here that I might pull up a few pictures. You guys do know Huey, Dewey, and Louie always pilot all of our flights, and if you don't know the story, someone asked us one time, how do you steer the balloon? And we came up with this story about we have specially trained ants because these pico balloons are very light. We can't put much weight on there. We couldn't put a frog on there. He'd be too heavy. So we had to go with these ants. And we said that we trained these ants for over a year, and they fly the balloon now. So that's how we do it. Let's look at a picture or two real quick. This is a tracker. It's sitting outside in the sun being tested. We are solar powered only, and no battery. A battery will not work at 45,000 feet. It's minus 40 degrees Celsius. It will not work. It freezes, and it will not charge, and it will not discharge, and that all starts happening around freezing temperature. So anyway, we're going pretty simple in this one. No amplifier. Last time, our last flight was 100 milliamps, I think, or 70 milliamps. This flight is going to run our standard tracker at 10 milliwatts. If you look at the picture, you can see the tracker right below the little green clip lead there, and that's the little tracker right there. It's got a 4.5 inch piece of piano wire sticking up. You can't see it, but that 4.5 centimeter antenna is the antenna for the GPS antenna. Now on 20 meters, we need a 20 meter dipole. That's 34 feet long. We have a 34-foot antenna on this tracker here, and that's for HF. And what we do, we take half the dipole, 17 feet, and we run it up a string to the balloon, and we let the other half, 17 feet, hang below the tracker and just dangle in the wind, and that becomes our 20 meter antenna. Now, one little difference we're going to do is we are going to still run dual band. So we've got this little tracker programmed here where we're not only going to have 20 meters, but we're going to have 10 meters also. So every 5 minutes we should get a report. The first report on 20 meters, 5 minutes later we'll get the second report on 10 meters. And propagation is different on different bands, so we hope that one will fill in where the other one didn't, So because of that, we can't really use just a 20 meter dipole. So we're using, and we have it built and ready to fly, a dual band trapped dipole for 20 and 10 meters. And I've got a picture here somewhere. Anyway, hey, this is W5 KUB 124. That's going to be the flight. And it's on a little 3/16 thickness of styrofoam. If you look underneath there, you'll see a couple styrofoam blocks, and the antenna is wound around that styrofoam block. And the antenna is made from number 36 wire, which is really, really small. And even the fishing line here is about the same size as the number 36 wire. Makes it very difficult to handle and work with. So you also see a trap there, one of the traps, one of the 10 meter traps there. Let's see. We're looking at it on the spectrum analyzer here, and that frequency right there is it's around 14. It's at the bottom end. It's in a whisper band. So you can see I've got a marker on it right there, a little number 1 marker. And on the spectrum analyzer, we're measuring a minus 10 dBm. That is actually 10 dBm, plus 10 dBm, because we're running a 20 dB attenuator. So you take the minus 10 and you add 20 and you come out with 10. So 10 dBm is 10 milliwatts. And so we know on 20 meters we're running 10 milliwatts. There are the traps we made. They made the traps out of a drinking straw, your typical drinking straw you'd get at McDonald's or wherever, we try to hold weight down. And, so we plug into AI, the diameter of the form. That straw is about 10 millimeters in diameter. And AI says we need 19 turns of about number 32 wire. And we need to put a 27 picofarad capacitor across it. The inductance actually is about 1.1 microhenry. So we build it and we test it with a spectrum analyzer and a tracking generator, and it was just about right on. And the way you can fine tune that coil, is just take a little X-Acto knife and just kind of spread the turns apart or squeeze the turns together, and that'll move the resonant frequency there. And these are set just right below the 10 meter frequency right there. So we've got 2 traps in our antenna. You can see the traps there. Both traps weigh a total of 1.3 grams, which is really, really light. 1.3 grams. There we're looking at 10 meters, 28 megahertz right there. Again, you can see with the marker there, number 1, we're right at minus 10. Add plus 20, and that gives us a plus 10. So that shows we've got 10 milliwatts on 20 and 10 milliwatts on 80. I mean, on 10. Well, I don't know why I said 80. On 20 and 10. I stretch that 34-foot antenna out in the shack. I run it actually through a doorway and down the hallway, and I take blue painter's tape and I kind of just tape it to the wall as we go down, and then I trim it. I trim it to try to get a good match on the SWR. You can see here on 20 meters, we're roughly very close to like 1-to-1 and 50 ohm impedance. So, that's probably about the best we can do. 10 meters is not so good with the trapped antenna. On 10 meters, we've got about a 2-to-1 SWR. Now, if you go to AI and ask how bad is a 2-to-1 SWR, it's going to tell you it ain't bad at all. In fact, since we're not running any feed line, no feed line to the antenna. The antenna is connected directly to the transmitter. So no feed line. You don't have feed line loss. You don't have SWR back on the on feed line. And AI says we're efficiently probably better than 95%, even with a 2-to-1. So I don't know. We'll see how it goes. But we do have a good match on 20. I don't know if I get any more pictures on this or not. Oh, that's a secret. Okay, so that's the story on that. Now, let's talk about how we get the data back. And before I do that, Brett's been listening. Brett, you got any questions?
Oh, well, it's pretty clear what you're up to. It's that trapped dipole.
Yeah.
Seems like a really good idea. But I guess my only question is, what have you tried it on any of the harmonically related bands? Can you go higher or lower?
Well, what with the trap dipole? Nah,
Yeah.
No, it's pretty much tuned for 20 and 10. Now, I did do this one flight this past year. I built a infed antenna, a 20 meter infed, and took a little bitty toroid and wound the toroid. What was it? 49-to-1 ratio, and we flew that, and it worked pretty good. In that case, the antenna started at the tracker, and the full, what is it? Let's see, a full wave is 34 feet. A full 34 feet hung below the tracker. And I think I did put, going up the rope, I think I did probably put a very short piece of wire for the, what am I thinking? What do you call it? What's the other wire? The counterpoise. counterpoise. And if you look at all the theory, I think the counterpoise is somewhere, the perfect counterpoise is somewhere around 0.06 percent of the I think of the wavelength. I have to look at that again, but that's very short. That piece of wire is 3 or 4 feet long, and of course some people don't even use counterpoise because they use their coax for it. You can put a choke on your coax at X number of feet back and do the same thing. Anyway,
how much power is this putting out?
This is 10 milliwatts. This is less than your typical garage door opener. 10 milliwatts, but it can be heard 6,000 kilometers away easily. We will be over, we'll be over the Middle East, and we'll be picking up reports in Australia and New Zealand easily. So it's all done through that secret whisper, weak signal propagation reporter. I don't know how they did it, but that 10 milliwatts will get out. Now, we've had a problem when we go into the stands, and everybody will tell you, when I say the stands are some countries over in near Asia over here. You got all the stands. You got Pakistan, and I don't know. I can't even think of all the stands. There's a bunch of stands over there. And believe me, for some reason, everybody says the sand below must suck the signal out of them because it's very difficult to get a lot of good signal reports as they go across the stands over there. Kazakhstan is another one, and Turkestan, and the stands. We just call them the stands. So,
Turkmenistan.
Which stand?
Turkmenistan.
Yeah. So I don't know, but anyway, so that's why we were wanting to try the 70 milliwatt, 100 milliwatt transmitter, that maybe it'd have a little bit more punch and it would help us. Now, what some people do when they have problems receiving that signal from the stands, they actually tune into SDR, these remote SDR receivers, and they're listed on the internet. You can log into and listen to a SDR receiver in Russia or anywhere, and that may get you closer to the stands, and you can actually decode it. I've decoded those through a SDR, remote SDR. Okay, so let's talk about how we get the data back, and it's kind of interesting what has to happen here. Again, we're whisper only, and we're solar power only, no transmission during the night. Solar power only, and since we're on two bands, we're gonna get 2 transmissions every 10 minutes, and what happens is, if you look into the technical details of Whisper has time slots, and the time slots are where you transmit. So on 20 meters, we are transmitting on the 2 minute and the 4 minute. Now each transmission of that is 2 minutes long. So we transmit W5 KUB for 2 minutes, starting on minute 2 and going all the way through minute 3. And then on minute 4, we send a fake call letter. We send a fake one. And a whisper set up to receive them, and it's basically I forget how many channels are available, but it's letters like call letters like nobody in the world has, so they're available. So our second transmission will be in the format of, and this is at minute 4 and 5. It'll come out and it'll transmit something like Q. I'll put an X where the letters go. The letter X could be anything from A to Z, but I'm going to say QX7 XXX, and each of those X's can change based on what the CPU is seeing up here, and I'll explain that in a minute. So we're transmitting 20 meters on minutes 2 and 4, and we're transmitting 10 meters on minutes 6 and 8. All right, so here we go. I'm going to try to explain how we get things back like voltage and so forth. So here we go. And we're at ground level.
Let me see. We're the only ones that are.
Let me start it over. Hello, everybody. Hey, it's July 4th. Have a happy July 4th, man, on its 250th anniversary of the United States. Hey, I want to try to tell you guys, or show you guys, how we track the pico balloons. You probably wonder, how do we get the data? How do we know the altitude? How do we know the voltage, location, and so forth? And I'm going to show you. I'm going to try to make it fairly easy. So I'm going to step through the different steps it takes to get the data to us and get it posted online here. So here we go. So we're going to start off with the tracker transmitting. I had it outside, but we're getting a thunderstorm coming in, and it's going to get pretty bad here in a minute. But here we go. Here's the basic tracker. We're solar. It just came on. The transmitter just came on, and you can hear it over here on whisper. All right, so let's get back and go through the steps here. So I've got this tracker programmed for dual transmit. It's going to transmit 20 meter whisper, and it's going to transmit 10 meter whisper. And that way, we can see different propagation, 20 meters, 10 meters, and so forth. So whisper has certain time slots. We transmit the 20 meter data to whisper on minutes 2 and 4, and then we transmit the 10 meter data on minutes 6 and 8. It takes 4 minutes to send the data. So I don't have an antenna on here, but we're transmitting, and we're in a shack. So our RF signal now is going out on 20 meters, and it's going to, it's in the air, and this receiver's picking it up. So the receiver's picking it up on 20 meters, and we have the WSJTX running, which is going to receive this information on 20 meters. Now, since we don't have an antenna on it, no one else is receiving it to put it up on whisper right now. So we're the only ones sending the signal up to whisper. So you can see we received it. The laptop here, whisper program, received it. There's minute 2. You can see 42. That's minute 2. Now we transmit 2 transmissions on 20 and 2 transmissions on 10. Those transmissions, the first one is my call, W5KUB. So we send that with some information. And then the second transmission we send is a bogus call. As you can see here, we're sending QA7JDB right here. So each transmission is actually 2 different transmissions. We've got our regular call plus a bogus call. There are a certain number of these bogus calls that you can use. No one else in the world has those. Those aren't used. So think of this profile here. That would be a QX7XXX. QX7XXX is the format. Now, so those digits, the XXX digits, carry specific data. And the Arduino is programmed to know and send
what each of those letters mean. For instance, one of the letters, is going to be a voltage. If it sends an A, that's 2.7 volts. If it sends a B, 2.8 volts. If it sends an L, it's 3.9 volts right there. All right, so we've picked it up on Whisper. We picked it up through our program on Whisper. Now this goes into the internet, and this sends that information to the Whisper database. So it goes to the Whisper database, and then it's now there for anyone to see. Now, if we were actually transmitting on an antenna, many other people would be picking up the signal, and they would also be transmitting it to Whisper database. But right now, since we have no antenna on there and we're at ground level, we're the only ones that are sending or relaying this information to Whisper. Now, once we send to Whisper, here in the office, we have a program running, which is a Python program. Let me click on it. And this Python program is set up to read that data from Whisper. So you can see here, it just read at 1945 hours, which is the last transmission, because the time now is 46 or 48. So we just read at 45 minutes, and we read the first transmission, and we've got W5KUB, Echo Mike 55. That gives us a 4-digit grid square. This tells me who sent it in. I sent it in. So the second transmission gives us a second batch of data, which is in this bogus format, QA7JDB. All right, so Q7 is the channel, and the A and the J and the D and the B all mean different things. In Python, basically knows what those things are. For example, it just sent a J. It sent a J there. So if we look up J, if we look up J here, we know that is 3.6 volts for J, and that's exactly what our little power supply is setting, 3.6 volts. The other digits tell us a couple other things. The other digits tell us things like the altimeter. We have a coarse. See if I can get a pointer here. One of the digits is coarse, and one is fine. So if we get an E in that field, the E in that field is going to say there's 4,000 feet, coarse, and in another field, if we get, say, an L, that's 660 feet. So it combines the 4,000 and the 660 to tell us that we're at 4,660 feet. So, okay, so our Python received that information. Our Python is converting those letters to numbers, meaning voltage, altitude, coarse and fine, number of satellites being received, and so forth. Then it is, if you'll notice here, the last two letters here in the second transmission, this dB, that adds to my grid square. I am grid square Echo Mike 55 dB. So that's a 4-digit grid square. When you add the dB on the end of that, it makes it a 6-digit grid square. So that gets you down to maybe 20 miles from where it is. All right, so once our Python receives this and does a conversion, it connects here to aprs.fi. And when we connect to aprs.fi, it sends all this data information that's been combined to APRS. For instance, it's going to say, we're at 3.6 volts, we're 60 meters high, there's the location and so forth, that's who sent it in and so forth. So now if I click on the map, now we're going to APRS. This sends it across the internet to aprs.fi. So when we go to APRS, let's see if I can find it here. Yeah, we go. When we go to APRS, it plots that information on APRS map. Now, note we are not sending an RF signal out to APRS. APRS is only via the Python program here to put us on the APRS map, because you can clearly see on the map and track it. So here we are. We just sent that last one. It was in the 48 minutes, 1448. And you can see it says 3.6 volts, 60 meters, Echo Mike 55 dB. That's because it took the Echo Mike 55 and it took this dB and it combined them. So it knows where we are within just a few miles. So what else can I say? So that's how we get it on APRS. The Arduino processor on the tracker is very good about reading the voltage, and you can use a simple 2-resistor voltage divider on the tracker, and from that point it reads the voltage, and in the program it knows that if our voltage is 3.3 volts, send a G. And I've already showed you how the G is interpreted and how it gets to APRS. So that's kind of the way it works there. It's kind of all done by magic, Anyway, I hope I covered everything. I probably left a step out, but you can see what we go through to get you a map on APRS. Now, things like amateur.sondayhub.org will also track it, but it pulls the information off APRS. So whatever sent to APRS is what they plot on sondayhub.org. All right, well. All right.
All right, so that's how we get there. What do you think?
Yeah, well, Whisper is a great thing to use because it really exploits Shannon's law, which says that if you send something very slowly, then it's intelligible a long distance away. It also has error correction, which is nice because it's more likely to get there. So it's a great thing to use rather than trying to use APRS, which has a very limited range. So the conversion into a call sign is a great hack. Are you the only one doing that, or are other people?
Oh no, there are other balloonists that are doing that. We can't take credit for that. But there's the Arduino has the capability of reporting voltage, but you've got to calibrate it properly. It can through that voltage divider, the selection of those 2 resistors has to be precisely done to come out with the correct voltage that it sends. So Mark in the chat room asked, have we tested the balloon package outdoors to simulate actual sunrise sunset? I really can't do it here. I have 100-foot trees all around my house, and and the sun almost has to get up to 40 degrees or higher before the tracker will start working. So I really can't. But that's a good point. The solar cells are laying flat and they're looking straight up, and it takes a solar angle. The sun has to be up at least about 22 degrees high before the solar cells will actually start functioning and putting out the voltage and the current they need to. So when the sun starts going back down, if that sun drops below about 22 degrees, the tracker will stop transmitting. Now, there's some interesting things to think about here. First of all, no matter where that balloon is in the world, I can tell you what the sun angle is. There's a website called timeanddate.org, and you can put that cursor anywhere on that map and it'll give you the exact sun angle at that given moment. And you can actually slide the slider back and forth and you can see at what time the sun angle is going to hit 22 degrees and so forth. So that's pretty interesting. Also on our website, our website w5kub.com, if you click on balloon in the top menu, we have a page set up to make it simple for you for tracking. At the top of the page, there's a link you can click on to get the APR's map. We also have embedded Sonde Hub map. You can see where it is. We've got several active maps there. We also have links and embedded websites that you can see what the weather is like. For instance, if we're flying 40,000 feet, we know where we are because of the GPS, latitude, longitude. And you can go to this weather website we've got listed there, and you can click on altitude, and you can set the altitude for the altitude that the balloon is flying, and you know the exact location of it. You can click right there, and it has the capability to show you if there's any storms there. You can click on how high the storms are. The last flight we had storms that reached 60,000 feet. We were only flying 40, so I'm sure that's what brought us down. You can look at the jet stream on that map, and you can see, well, we're not in a jet stream. We're only flying 20 miles an hour, but sometimes when we move up into that jet stream, we may be moving 140 miles per hour. You can also check Sonde Hub. You can click on predicted path, and it will actually show you, just like when you watch the news or the weather on TV and you see the hurricane prediction map, you'll see different colors and the track that all the different models are telling you it's going to go. The same thing here. In fact, the tracking prediction is through NOAA for this. So, we can say, show us the predicted map, and it'll show us like 7 days out. It'll do all the dots, all the different color dots and the different models, and it'll show you where it's going to go, and you'll pretty much know where it goes. Now, we're going to be going over, if we make it across the ocean, we're going to be going over probably Ukraine, Russia. So I don't know. There's a lot of GPS jamming and spoofing over there. The balloon may be over. Moscow, but it may report on the map that it's in Mexico City when they're jamming or spoofing the signal. But once it gets out of that area, it's going to come back on and tell us where it is. So if you see it going from almost from Russia down to Mexico City, that's bogus right there. Anyway, so that's kind of how we get it back. Apologize for the camera work. I had one hand in trying to think and explain it, but that's how we get data back and how we get it on the map there. So with it here on the ground, the 10 milliwatt signal just will not get into Whisper. It won't pick it up. It's not strong enough. You may have noticed in my window, I had a couple wires went out the window. That was a little vertical piece of wire out the window there. And I could clip lead that on the tracker. And usually the 10 milliwatts won't even make it into Whisper. But when we were running the 70 milliwatt transmitter, it was being picked up all over the United States from ground level. So anyway, that's I hope to announce that we're going to attempt another flight this Saturday, but I'm looking, there's a 50% chance of rain and winds 10 miles an hour or better. So I don't know, it may be another week before we actually get to transmit it or get to launch it and so forth. All right. So I hope that answers some of your questions. Let's see, Mark says the reason he's asking that question, it would simulate voltage variations and place a good test on how the Arduino starts, operates, shuts down, and the next day's operation. Yeah, it would. We do know from flying, our previous flights that about 20 degrees is the magic elevation. Now, we have sent solar panels up that were on a V shape, like a roof. And we had solar panels on one side and solar panels on the other side. And we got down to 0 elevation with the sun. In fact, I think we had reports of minus 5 degrees sun. But that's with solar cells tilted down like a 45-degree angle. So you can see at a 45-degree angle, if the sun is coming in just straight from the horizon and the cells are at a 45-degree angle, it's going to be within that 20 or better range. So, but anyway, when we do that, we learn a lot of different things like that. We try experiments like that. When we do that, though, and put cells on both sides, that increases the weight. Now we're doubling the weight of the cells. We're doubling the weight of the styrofoam that has to hold the cells, And one thing about these solar cells is the ones in the dark will suck electricity back from the ones that are in the sun. So in other words, what we have to do is put like a Schottky diode in the lead from each set of cells. That way the voltage can't feed back into the cells that are in the dark. On this flight, we're running a single set of cells, and we're keeping it simple. We have flown APRS trackers before that would report directly, to APRS. But the problem there is the range. It's been so long since I've flown them now, I don't remember exactly. That didn't last long. An APRS transmitter will only track, say, maybe 200 miles, a couple hundred miles. And when it gets over the ocean for 3 days, you don't hear from it. When it gets over Africa, North Africa, you don't hear from it. It goes across the stands. You may not hear from it for 7 days or 8 days. And you wonder, did it go down? Is it still flying? But with using Whisper, and then by the time we get to China has some APRS. So when we get China, we start picking up the position again. But then guess what? We got the big Pacific Ocean out across. Now when we get to near Hawaii or somewhere like that, on APRS, possibly pick it up, lose it again until we get to California. So that's why we fly Whisper. It'll go 6,000 kilometers easy. So that's why we fly it. And that way we can watch it, just all the time. And we don't have to worry about that. All right, so just one other little thing you may have seen on this tracker. We're keeping this one real simple. We're keeping it real simple. Let's see. You can see that little blue capacitor there. That's actually a super capacitor. We typically don't fly them on Whisper balloons. We don't need it. APRS is a pretty long transmission, and it's pretty current hungry. So we typically needed a super cap to help supply the current and voltage that we needed with APRS. Whisper, most people don't fly a supercapacitor. We have decided to fly a supercapacitor, and here's why. Once that tracker, and I've got that, I put that the voltage into that tracker can be up to 6 volts, and those cells, seven cells, 7 times 6, it can get up to 4.2 volts. So we can go up to 6 volts input to the tracker, but then the tracker runs on 3.3 volts. I've got that super cap across the 3.3 volt rail because it's only a 3 volt super cap, and it would blow up if I put it across the 5 volts. We put it across the 3.3 volt rail. That way, we only need one supercapacitor instead of 2 3.3 or 3 volt capacitors in series to handle the 6 volt, or whatever. So anyway, so back to the point why I put this on there. With solar cells, with solar panels, you only have voltage when it's in the sun. If the voltage turns off, that tracker will have to reboot and go through all the process of rebooting, and the GPS will have to, get a GPS lock again on the satellites and so forth. So just think, this thing's flying in a jet stream, 140 miles an hour. We think it looks pretty steady in a jet stream. We think it's all relevant. In other words, if the jet stream is moving 140, we think the tracker is moving with it 140. That and that indicates that it's not blowing around. It's just moving the same as the wind. Just like a cork in a river. It's just floating with it. So, but we don't know. We've never been able to get up there close enough to look and see what that thing's doing when it's flying. So here's what I'm thinking. If it, and surely you've ridden airplanes and you've hit turbulence, and winds change and winds meet each other. So I'm thinking, I don't know if anybody else has thought, but I'm thinking that if this thing does flop around just a little bit, most of the time it's steady, but let's just say it hits some kind of gust and it flops just a little bit and it gets out of the sun, well, guess what? It's going to have to reset the processor, and we're not going to get a report probably for another 10 or 15 minutes. But that little supercapacitor right there will hold the voltage and run that tracker for over 2 minutes in the dark. So if it does flop into let's say it flops into the darkness for 2 seconds and comes back, hey, we don't even see that. It could flop in here for 8 seconds and come back, and it's still running because the supercapacitor, that one is handling it for upwards to 2 minutes. So that's the reason we put it on there. And 3 or 4 years ago, supercapacitors were even much bigger than that. They were 3 times, 4 times that size, and added a lot of weight. I'm surprised at how small these are getting now. That one right there is a 10 farad. Man, when I first got my license, a 10 farad would have been the size of my car. I mean, now look at the size of a 10 farad, So anyway, that is kind of what we've got going there. Let me check the chat room here. Okay.
I got a question.
Yeah.
Yes. Do you find that your whisper transmissions ever get interrupted because you've run out of power? The reason why I ask is that a whisper transmission is about 2 minutes.
Well,
So
whisper,
you're
yeah.
with the capacitor.
Well, we don't know, but here's the thing. We've always flown it without a supercapacitor, and we've had 99.9% connectivity, so we feel like it's staying in the sun. My putting a supercapacitor was on there is if that thing just takes a blip and just flips or comes back. If it flips and comes back, the power goes off. But a flip and come back might last 2 seconds. But here, man, if I've got it in the shack here, and if I take the power supply off of it, you can't kill it. It's running for another 2 minutes. So we've got the 20-meter transmission is minute 2 and minute 3. That's 2 minutes, and then minute 6 and 8. That's another. So we're transmitting 8 minutes out of 10. We're transmitting 8 minutes out of 10. But I can take this thing out. It's completely dead right now. I don't have a switch on it to turn it off when the battery goes down. But and I'm glad I don't have a switch on it, because I think some people have launched these and forgot to turn them on. So we don't deal with that. So I can take this thing outside, even with that 10 farad, and you think, oh man, it's going to take. Some people think it's going to take 30 minutes to charge that 10 farad up. It's not a problem. I can take this thing out in the sun and set it out there in the front yard, and within 1 minute almost, about 1 minute, I start receiving whisper transmissions. Now, the tractor, the supercap may not be charged completely, but the voltage may be low. The voltage may be 2.9 volts, but the cells are providing current, and some current's coming from the supercapacitor too. They kind of share things. Okay. All right. So let's see. What did I have here? What else we got going here tonight? Okay. So, hey, the other thing I was going to...
You're going to talk about, let's see, Huntsville?
Huntsville's coming up. Next week we'll have Mark Brown on, chairman of the Huntsville Ham Fest, and that'll be good. It's August the 22nd and 23rd. We're going. We always go. It's going to be nice. I'm surprised after we talked Brett in going. He's going every time now, man. You must like it.
Yeah, it's a lot of fun, and I like some of the extracurricular events that surround it as well. There's always events at the Signal Museum, and there is a big POTA party on Montesano the day before the convention starts, and that's always a ton of fun. So I go up there and I camp out with them. They have a big cookout for breakfast and a big cookout for lunch, and there's a lot of tech talk and a lot of socializing. It's great fun.
Great. Well, have fun up there on the mountain. Hopefully it'll be cool. Hopefully you won't burn up there.
There's lots of trees. It's shady. It's really nice. This year I'm even renting a cabin.
Yeah, you said that last time. That'll be good. So August 22nd. What day you coming in? I guess you coming in on Friday or Thursday?
I'm coming in on Thursday.
Yeah.
And the big cookout is on Friday, and again there'll be lots of people there with all sorts of POTA gear. We will probably do parachute mobile again the way we did last year. There's a fellow named Carlos who likes to jump out of airplanes, and you can contact him on the way down.
Yeah, we've had Carlos. We've had Carlos on here a few times. Yeah, that's interesting. Okay, well, very good. We'll talk a lot more about it next week with Mark Brown. Let's see what else is going on. Oh, man, I thought it never happened, but I got fiber. Look at this. Look at this, man. Look at this.
Important to a healthy diet.
Look at this. Hope what?
Important to a healthy diet.
Yeah, man, fiber. And let me pull the other camera up here. Let's see. Where's the camera? Where's the camera? Right here. See if I can show you. This is one of the smaller fiber cables, but this is it with the jacket. This is the jacket right here. They've run several of these out there. Hey, this particular one is foot number. Wow, 1, 2, 3, 4. It's 6 digits, but it's only 7,746 feet, and then right here is 47 feet. So man, that's a lot on that spool, man. 7,000 already they done pulled off. This is one of the smaller cables, and this is what's inside it right here. Most of this thing is a filler This feels like some kind of hard Teflon or something right here. This is just to give it strength. And then here are two small fibers that are in that one I just held up. I don't mean two small fibers, because each one of these has 12 in it. So if we look at the fiberglass here, we try to get it apart. Man, this is some tiny stuff, man. That's two of them. That's two of them together. Let me separate them. There we go. Look at that. Whoop, that's still two. Oh, there we go. There's a fiber. Let me get a dark one. Gee whiz. Let's see if I can get that blue one right there. Yeah, there's a green one and a blue one together. I went out and talked to a guy putting the stuff together here the other day, and it's kind of neat. Here we go. There we go. Ben, hair on your head. Where is it? Hair on your head. This is glass. That's glass right there. And what they do, guys, they got a little machine. They stick this in there, and they stick the other one from this way in here, and it welds it together. It welds the glass together, and that's how they splice it together. I think I've got another picture here. Let's see. I think I got another picture.
And the inside of that, which is the fiber, is only 125 microns, so it is really thin.
Yeah. There we go. That's one of the things that are going in a box out in front of my house. That will feed 12 people. 2, 4. That's this 2, 4, 6. That looks like 8. But that would be the connections to each of the homes. And my understanding is out here, he says, we're going to have one fiber basically dedicated to each house. I don't know how they do that. It's not, and I asked, it's not like 3 or 4 or 5 houses here are sharing one of these. It's everybody's going to have an entire fiber, I guess, back to a certain point. Don't know how they do that. But this is
a neighborhood hub, and there's a pedestal somewhere in your neighborhood on a street corner for a group of houses.
Yeah. Well, they put a box in front of my house, so it's about 2 foot by 3 foot probably boxes in the ground here. Okay, so I'm getting fiber, guys. I'm gonna have a gig up and a gig down. We'll when I get that, we're gonna set the show on I don't know, let's try 500 meg up. What do you think? Oh boy. Anyway, let's see. Hey, you saw a picture here, another picture I had here, guys. This is non-ham related, but it is. We bought that truck for Amateur Radio Roundtable, and we drove it to Dayton probably for 20 years. And I finally put a topper on it back there. We used to have to tarp everything down. And I bought that topper, and boy, that was really nice. We put stuff in here that didn't get wet or anything, because it always rains going to Dayton. But we actually went out and bought Kathy a car today, another car. She drives a Volvo, but we bought her a Lexus today. I've decided I'm going to drive her Volvo because it's smaller than my truck, and man, that thing runs like a race car, and it's easy to park. Now, my truck, it's semi-hard to park. You get into some of these parking places, doctor's offices and places, you got to be careful parking that thing. You have to hunt, where you're going to park. You just got to be careful. It's just so big, it's hard to handle. Plus, I don't need a truck anymore. I'm not going and doing big Hamfest anymore, so I don't need a truck anymore. And third, I've got friends that got trucks. If I need a truck for an hour once a year, I'll just go borrow one of their trucks. So, here's the question. I know you guys are experts in this field. I'm putting that up for sale. Probably sell to an individual. A dealer's not going to give me as much as I can get for an individual. It's a 2010, but it has very low mileage. That truck should have about 200,000 on it. It's got 92,000 on it. Perfect shape. You can see it there. I talked to a dealer today. I told him I wanted 13 for it. He says, I'm probably in the ballpark. He said, yep. He said, I'd list it for $299. Anyway, I'm going to try to sell it. I hate getting rid of my pickup. I'm a pickup guy, but man, I don't need it. And it's hard to park. And I'm getting older. I thought, well, I can keep it and we could have 3 vehicles, but there's no need to the thing sitting out there and getting sap dropped all over it for, all year and me not driving it and paying insurance and all that on it. So here's the challenge. Everybody tell me what I think I should ask for it. Tell me what I should ask for it. The Lear topper on there sells anywhere from $2,000 to $3,000, and the tires are like brand new, completely clean inside. Looks like a brand new vehicle inside. I don't have any damage to the vehicle. You can see there. So tell me what you think I should ask for that truck, and I'm gonna put a for sale sign on it probably tomorrow. And hey, I'm gonna set it out in front of Walmart, and I'll probably get a bunch of calls. Tell me what you think I should ask for that truck. I think I'm at my top limit of $13,000, but anyway, I think I can get it. All right. So, wow, a lot going on here. I'm getting rid of my truck, man. You think I ought to get rid of it?
I don't know. Might come in handy.
Yeah, it might. I might need it in an hour, 8 months from now. Yeah, I might. Gee.
But that kind of truck, that's a Suburban?
No, that's a Silverado.
Silverado.
Yeah. 1500.
Yeah, I think you're in the right neighborhood. Talking about between 13 and 15K.
Yeah. It's a pickup. It's a short bed pickup. It's 5.5 foot, and that's a topper on the back. Yeah. Mark P.
And adds extra value.
Yeah. Mark P. And I upgraded the radio in there. What do you call the system? The GPS and all that's been upgraded. Mark P. says 14,000 with some spare tubes thrown in. I can do that. Mark, you want it? Send me down a cashier's check, Mark, and I'll let you drive it home. Here, let's see. Don't regret it. If you could garage it, you could justify. Yeah, I could garage it. I have a 3-car garage. You can see the picture there. I've got a 3-car garage, but that single garage is my shop. That's where I'll do all my welding and grinding and cutting and building. So I don't want to lose my shop, and I just don't want to set it outside and all that. So, Mark, come on down and get it if you want it, Mark. I'll cut a little off that.
My wife is in the market for a pickup, but she needs a lung bed. She likes carrying 4x8 sheets of things.
Yeah, well, you can carry that in there with the tailgate down, Yeah. So anyway, that's where we are. Let's see. I'm look at my list here. We talked about field day. I showed you my fiber I've got here. Oh, one last thing, real quick. Do I have it here? Oh, yeah, I got it. It's on my phone. So, guys, I've got a couple spectrum analyzers. I had a really nice one here a couple years ago, and it went bad. It seemed like they all go bad. It sold for about close to $30,000 new. It was a pretty modern one. It went bad. I tried to. There's not many people that work on them, and people that do work on them, they want $1,000 to repair it. So anyway, I sent it to this guy, and he just swapped me. I sent him the bad one. It had a carrying bag and everything. I sent him that one, and he sent me a smaller commercial spectrum analyzer. Now it's gone bad. But in the meantime, I had bought me a Rigo 845 or whatever with tracking generator. And that's what I use mostly. But I turned this one on the other day to just play with it. And it didn't come on. The screen didn't light up. Actually, it did light up, but it was real dim. And I asked the AI, I said, I've got this model. And here's what's happening. Boy, it walked me through a lot of things, man. It says, can you see this? Is this function here working? And I said, no, I can't see anything on the screen. It says, if you turn the lights off, can you see anything on the screen? So I turned the lights off, and bam, there it was. It was just real dim. And he said, okay, here's the research based on this and the tech books. There's three things that it can be. One is an LED light driver or something. And another one was like the filter capacitors. The capacitors go bad in these, really bad. So I thought, okay, I'm gonna work on this, and I'm gonna open it up. It's probably a capacitor, and I'm going to just, slap me another capacitor in there. Now, I started opening it up. Man, what a mess. Not a mess. This thing is built like a tank. It has so many shells and boxes and cans inside. I started pulling screws out. After about 40 screws, I still couldn't get the cover off the power supply because there were more screws under a bracket, which you had to take off another shield before you could get to those screws. But I couldn't get to those screws because I couldn't figure out how to get the front off. Oh man, it was a mess. But let me see if I can, let me pull it up here. Oh, there we go. Let's see. What's going on here? Oh, there's another picture. Let's see. Okay, who wants it? I'll cut you a deal, man. I'll cut you a deal. All right, so, okay, there's the screen. And of course, you see the reflection of me. That's the bottom. You can see it was in pretty good shape. I mean, there's a bottom, no scratches or anything on it. One of the sides, the handle. By the way, this spectrum analyzer sold for about $16,000. It's not a cheapy $1,000 one like I've got up on the workbench right now. But there's the back of it. You can see it's in pretty good shape. It's even got little covers on the BNC connectors. I don't know if I got a picture inside or not. There's the inside, man. I mean, I tried taking that cover off on the right side there. There ain't no way I can get that cover off. There's too many things covering screws that you have to take other brackets off and take the front off, and I couldn't even find screws to take the front off, to tell you the truth. So anyway, I decided, I just buttoned it up. And I decided I'm just going to sell it on eBay. Somebody might think they can fix it. I put for parts only. I'll sell it for $250. If people are interested, I'll probably come down, but I don't need it. There's the one I've got right there. There's the Rego, which is a nice one, and it also has a built-in tracking generator, which makes it really good for, looking at traps and inductors and all kinds of stuff like that. So anyway, that's my story. And I'm sticking to it, I think. Okay. Let's see.
It's hard to tell whether that thing needs new LEDs or a new power supply, but
yeah,
probably.
and after you even take the cover off, you can't even get to it, man. You just can't get to it. It's, man, I mean, it is so shielded, and I mean that's not cheap shit. That's some heavy metal in there. Yeah. Well, let's see. Mark said he drives a 95 S10. Yeah. 15K. Okay.
Oh. 95.
What frequency? Mark wants to know what frequency. It's I think 7 kilohertz to 2.7 gigahertz is that one. It goes up to 2.7 gigahertz. All right. Well, guys, I think we have pretty much covered everything tonight. Hit the like button, hit the subscribe button. We will see you in 2 weeks. And we're glad you were with us tonight. And KA2OFM. You'll get your prize soon. 73, everybody. Good night, everybody. And let's see. I had something here. Wanted to run. Don't know what it was. We'll just do this one again.
Amateur Radio Roundtable! The best ham show Join Tom, W5 Cub, and Brett, Y7BG. Talking antennas, DX, and radio fun. Making friends around the world, one contact at a time. Amateur Radio Roundtable, where the ham radio world comes together.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.